In this video, we will talk about problem D, non-palindromic substring from Codeforces round 934. A string is said to be k-good if there exists at least one substring of length k which is not a palindrome. You are given a substring in a query. You need to figure out the number of valid k for which this string is k-good. This is an experimental video where I'll go over my thought process instead of explaining the entire solution in detail. We will see how the next step logically follows from the previous ones, and you can solve this problem in 10 easy steps. If a string is k-good, then at least one k-length substring is not a palindrome. From intuition, you can feel that if you generate a string randomly, there is a very high probability that it will be k-good. Therefore, we feel that the size of the complement set might be small. Therefore, the strings which are not k-good, they probably have a special structure. Let us investigate them. If a string is not k-good, then all the k-length substrings are palindromes. Now, how do you visualize all the k-length substrings systematically? You can do that using the concept of sliding window. This is the first substring of length 5. To generate the next substring, you will remove one element from the window and you will add one element to the window. Since this string is not k-good, then by assumption this blue line is a palindrome. But the orange line should also be a palindrome. Therefore, it makes sense to investigate what happens when you slide a palindrome to the right one step. From experience, you know that palindromes have different structures depending upon whether the length is even or odd. Therefore, it makes sense to investigate both of these cases separately. If the first window was a palindrome and you introduce one element and remove one element, what can the incoming element be? Of course, it has to remain a palindrome, so it should match with B. So B should appear over here. But then C should also match with A. So you can replace it with A. So you have a hypothesis over here that the string should contain alternating characters. But let us verify this hypothesis once more. If you have length k is equal to 7 and you have this initial palindrome and you add this element to the window and you remove this element from this window, then the incoming element has to be equal to B. So you write B over here. But C should be equal to A and D should be equal to B. So you again confirmed that the string indeed has to be an alternating sequence of two characters. And in retrospect, it actually looks pretty intuitive on why that might be the case. Because every time you remove an element, you need to add the element that is after the removed element. So it makes sense for the alternating sequence. Now, what about the case when k is even? If this element is going out of the window, this question mark should be equal to B. But also A should be equal to B. So therefore we have a hypothesis that the string should contain identical characters. Let's verify this hypothesis. If you have k is equal to 6, then this element should be equal to B. But C should be equal to B and B should be equal to C. So combining all of these, you can see that all the elements indeed need to be equal. And again, it's pretty intuitive on why that is the case. Because if the length is even and you slide it to the right, then this should be equal to this. Only then will it remain a palindrome. Now we have the algorithm. If the string contains all the identical characters, then you cannot find a non-palindromic substrings. But if it has alternating characters, then you can see that only the even length substrings will contribute to the answer, because the odd length substrings are themselves palindromes. Otherwise, if the string does not follow any of the two strategies mentioned above, then every k greater than or equal to will contribute to the answer. There is a small bug in the previous algorithm which you can either discover by thinking about the algorithm again, or you can code up that solution to receive a wrong answer on the sample test cases to point out the error. The error is that the length equal to k should be evaluated separately, and these will only contribute to the answer when the entire string or this given substring is not a palindrome. Now, why do we really need that special handling? The reason is because all the arguments we have made so far was based on the fact that we will be able to slide the window to the right at least once. But if k is equal to length, then there is no scope of sliding the window. Therefore, the arguments do not hold over here. Therefore, you need to manually check if the entire string or the given substring is a palindrome or not, and accordingly add the contribution. Now, how do you figure out if a substring contains two alternating characters? It's pretty easy if you have dealt with string algorithms before. All you have to do is create 26 different vectors, and in each of the row you populate it with the frequency of that character at that position. So the columns will represent the indices of the string. Then if I were to ask you the answer to this particular substring, then you just need to figure out the row corresponding to this character, and then once you have the row, you have a 1D array. In this 1D array, you just need to find the alternating sum. And this technique of finding the alternating sum can be easily done via prefix sum. And this technique I have also described in my video on distributing DP, which you can watch on my channel. Then you find the alternating sum of the second element of the substring. And once you have both the alternating sum of the first element and the alternating sum of the second element, you can simply sum them up to see whether their sum is equal to the length of the substring. If it is, then it means that the string does contain alternating characters. If not, then the answer is no. How do you check if a substring has identical characters? This is also pretty easy. All you have to do is find the alternating sum of the first element of the substring and the alternating sum of the second element of the substring. And if the string is indeed alternating, then you just need to check if the first element is equal to the second element or not. If it is, then it means that the entire substring contains of identical characters. Finally, how do you efficiently figure out if a given substring is a palindrome? You can do that by taking that substring and hashing it to an integer. Then you take the reverse of that substring, hash it to an integer, and then compare it for equality. If the hashes are equal, then with a very high probability, the original substring will also be a palindrome. But what if you do not know the hashing techniques that are used? You can still solve this problem just like I did, because the USACO library provides a mini library for string hashing that you can use as a black box by just knowing what hashing is and what it does, right? You do not need to go into the internal details of the library. This is the hashing library from the USACO guide. All you have to do is copy paste this template and provide it with a string that you want to hash. Then to get the hash of a substring, you just need to call this getHash function with the 0 based index of the starting and ending element of this subarray, and it will give you the hash in O of 1. This is my code for this problem. As you can see, I just copied over the hashing library from USACO guide. Then I take the strings as input and hash the string and the reverse of the string. Next, I create the 26 different vectors with the frequency that we talked about earlier. Then I iterate over each of the row and convert it to an alternating prefix sum vector. Parallelly, I write a utility function that can give me the alternating sum for a particular row. Then I process all the queries, find the alternating sum of the first element of the window and the alternating sum of the second element of the window, and if the sum of both of these is equal to the length, then it means the string does contain alternating characters. Then I check if these characters are equal. If they are, then it means all the characters are equal, so the answer would be 0. Otherwise the answer would be the contribution of all even length substrings. Finally, if none of these conditions are satisfied, it means that all k greater than 1 will contribute to the answer, except possibly the k is equal to length. And how do we determine the answer for k is equal to length? You just check whether that substring is a palindrome. To do that, you can use this getHash function from the USACO library. And of course, when you reverse the string, L and R would get swapped. So using this technique, you were able to solve this problem in 10 easy steps. You can find my code on cfstep.com, and I will also link my code in the YouTube comments.